So our topic for today is applications of relations and databases. So before we will start our discussion, do you guys have a question or clarifications regarding our topics last meeting? Anyone?
Wala naman po, sir.
All right. How about the others? Do you guys have a questions or clarifications regarding with your seat works?
Answer.
None, sir.
All right then. Okay. So if you guys do not have a question anymore, then let's now start our discussion. So the first one here is relational databases. So what is this relational databases? So as you can see, for us to be able to see that one is relational, it must have at least two or more columns or two or more sets to be exact. Okay, so that is why we have this by from the word or from the meaning itself, by two. Okay, so by in a relation R refers to binary which has two columns in a table. So a table that has an n columns is called n-ary relation. Right? So this is a column, 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 and then column. And then those columns are called n-ary relation. So this uh, column is related with this column, and this column. So they are related by name, position, and then age, etc., etc. So those or this table, this can be expressed as the set of 22012. So where this one came from? This one came from the second row. Okay, and then followed by the second row, second column, which is Aguilar, and then third column, which is C, and then fourth column is 22, and so on and so forth. So this one is your third row, first column, second column, third column, and then fourth column, up to five uh, tuples. Okay, so this is your first tuple, second, third, fourth, and then fifth tuple. So as you can see, each row is called tuple. Okay, and then this one is called attributes. Okay, so we have the attribute ID number, we have the attribute name, and then we have the attribute position and then age. All right, so first you have to know the word database, okay, from this table. So this is actually already an example of a database. So as you guys already know, so database is a collection of records that are manipulated by a computer. Okay, and computer systems are capable of storing large amounts of information in databases. Okay, so you guys might be wondering, what does a data look like in our computer? Well, to be exact, if you're going to use, let's say, PHP or any other databases, so they are just quite similar with each other. So they have, of course, the attributes and then tuples. Okay, so of course, each one of them can be identified by its coordinate. Right. So yeah, so tuple refers to a record or rows, just like what we have in here. We have five tuples, and then attributes is the fields or columns of n-ary relation. So in here we have four attributes. So as I mentioned a while ago, we have the ID number, name, position, and then age. So those are our attributes. And then we have here the key, which is the most important part of our databases, or database. This one consists of one or more attributes that uniquely identify a tuple. Okay, so as you can see right here, we have the ID number wherein each tuple has its own unique ID number. So the rest, for the name, they can have the same names, they can have the same positions, they can have the same age, but they cannot have the same ID number or the same key. So this is the like serial number on each tuple, okay, or on each row. Okay, so this one is representing their own identity. Okay, and last one here is query. So query means a request for information from the database. Okay, so we have a lot of queries. So basically, we upload and then we fetch or download that data. We can also delete. We can edit, we can update, etc., etc. Okay, so those are the queries that we can request from the database. All right, so let's have a short exercise from this one. So identify the tuples, attributes, and key from the table below. So first, tuples. So what are the tuples from this table? Or how many tuples do we have?
5, sir.
So yes. So again,
Five.
you will not include this one as your number one tuple. So this one is your attribute. Okay. So you will start right here. So first tuple, second, third, fourth, and then fifth. Right. So we have total of 5 tuples. How about the attributes? How many attributes do we have?
Four.
4. Right. So as you can see, when we say tuples, it should be equal to row already. Okay. But then again, do not start at the very first. Start at the second one. And when we say attributes, it is talking about the attribute itself, which is the row. Okay. Which is the very first row and just the very first row. That is your attributes. Okay. So your ID number, name, position, and then age. And then the key from the table below. So what are our keys? Say what is the key number of Baterina? Anyone? What is the key number? Or what is key
Five.
of Baterina? Yes?
58199. The ID number and the age, I think.
Yes. Okay, so it's under attributes called ID number 58199. So in some cases, we call this one ID or just account number or what else? You can even call this one key, okay, to be exact. Okay. But mostly this one is account number. All right, so we have here the operators. So join, operator, union, and intersection and the difference are already familiar with you guys. But we have a new two in here, which is the selection operator and then the project operator. Okay, so to make it simple, when we select operation or selection operator, we have here this symbol. Okay, once you see this symbol, meaning this one is showing you the entire row of that specific coordinate. Like for example, select and then the name of this table, and then let's say position C. So it will only show this entire row. Okay, this one row only, which has a position of C. Okay, and then when we see project operator, okay, so if we have row, we also have column. So this will show you guys the entire column of a certain table. So for example, when we say project ID number and the name. So it will only show you the uh, column ID number and then column name. Okay, and then it will remove the position and then age. So that depends on your way of uh, querying things. Okay, and then we have your join operator. So as you can see, join operator is just like combining two tables. Okay, so simple as that. And then when say union, you will only combine the common. No. You will combine everything, but then remove the common. Call this one common attributes or common elements inside of our table. Okay, and then when we say intersection, it will only combine the similar or common elements or attributes in our table. And when we say difference, so this one also depends on your format. So the first one will retain, like for example, table 1 minus table 2. So table 1 will retain, and then the commonalities of table 1 and table 2 will be removed. Okay, so that one is if T1 minus T sub T2. But if we have T2 minus T1, so it's the other way around. So T2 will be the one that will remain, and then the common of T1 and T2 will be removed. Right? So first we have here the selection operator, wherein we have the symbol. Actually, I don't know the name of the symbol. I cannot find because I don't know what to type. Anyway, is there anyone who knows what is the name of this symbol? All right, so I guess none. But anyway, this memorize is one. This is the symbol for selection operator. Okay, so this one chooses certain n tuples from a relation. So tuples again is indicating the row. Okay, so we have here the syntax: select and then the name of that table and then your condition. So we have an example here. So select players. This one is table player, okay, or the title of this table is player. That is why we have this player here. And we have here the condition wherein the condition here is position is equal to P. So under attributes position, you're only going to show the tuples wherein it has a position P or position equal to P, wherein we have two. So we have this tuple and then this tuple. So as you can see, that's the output. It will show you guys the entire tuple or entire row of that specific coordinate. So coming from Mr. Tanikala, so he said that this one is delta, right? So thank you so much. So the symbol for selection operator is delta, right? So yeah, that's how we get this output coming from this format or example. So did you guys get it so far?
Yes, sir. Gets naman.
All right. So again, this memorizes format or this syntax. So we have this delta and then the name of that table and then followed by the loosen up in bracket and then your condition. Okay. All right. Let's have more examples. So find the output of the following commands. So we have the same table and then here's the first question or first example rather. So select player age is more than or equal to 30. Okay, so of course it will only choose the age that is greater or equal to 30. So as you can see right here, we have two. We have the Costa and then Hontiveros. So this one is equal to 30 and then the other one is greater than 30. So as usual, it will only display two tuples. Okay, so take note when you're going to use this operator, it will display the entire row. Okay, you don't have an option to remove the ID number and then just display the name, position, and then age. Okay, so if you want to let's say remove the other attributes and just retain some attributes, then you have to use the projection. Okay, because in that way you will be able to uh, format it uh, more customizedly. Okay. All right, so we have another example here where in select player name is equal to Acosta. So basically, you'll just go to the attributes name, and then it will only display the name that is equal to Acosta. So we only have one, so of course it will only display well, just like this. And then we have another example here wherein you're looking for the position is equal to P and age is greater than 30. So you can have as many conditions as you want. Okay, so just use the operator and or. Okay, so in here we have two conditions wherein they should met at the same time, so they should be true at the same time, and then it will display that table wherein position is equal to P. So let's look for P. So we have two, but then again, we have another condition wherein age should be greater than 30. So if you're going to take a look at this one, there's only one tuple that is meeting the two requirements. Position is equal to P and then age is equal to 30. So of course, it will only display this tuple since this one is not meeting the second requirement or second condition. Right? So that is why we have only one tuple. So did you guys get this one so far?
Yes, sir.
Yes, sir.
All right. So if you have a question or clarification, so feel free to ask me anytime. All right. So let me introduce to you guys the commands under select. So we have 5 commands. So those are very common already. So we have the summation, average, minimum, maximum, and then count. Right. So I guess there's no need to explain those commands anymore. So they are already self-explanatory. Okay, so let's now proceed to the example. So write the commands for the following queries. So what is the average age of all the players? All right, so let me answer this one. So for letter A, so again, course, we're going to use select. So let's see if we can copy this one for us to have a better presentation of answer. No, we cannot. So instead of using this symbol, we'll just use the word select. Okay. And then followed by the table name. Of course, the name of this table is player. So just be careful of the format of your table name. If we have this format, let's say small letter E, and then everything is capital, then so be it. Please follow it carefully. Okay. So this one is equal, not equal with this one. Okay. So this is another table, and then this is another table. All right. So just be careful on the namings of the. So in here we have this name of the table player. Everything is capital, followed by the condition. Wherein the first question here is, what is the average? What is the average age of all the players? So just put here age is equal to average, okay, or AVG. Okay, so this one will compute the average of that attribute. There you go. So this is our answer in letter A. How about letter B? Well, yeah, how many players are there? So anyone who wants to volunteer?
Sir, name equals 5.
Name is equal
5, sir.
5? No, 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 no. Of course, we're going to use the commands. Okay, so we're not the ones going to indicate the list or the
Huh?
counts those of this one
Name
players.
equals max, sir.
So name is equal to count. So this one will return the frequency of a certain attribute. Okay, so this one name is equal to count. So we're just basically going to count the frequency of this attribute name. We're in, of course, it will display, or this one will display 5. Right? So let the computer solve it for you. Okay. How about letter C? Select how old is the youngest player. So basically the same table name, but just a different condition. Anyone?
Sir,
How old is the
equals
youngest?
minimum.
So is what is the attributes that I will put here?
Age.
Min.
Age is
Age
equal
equals to
to
mean.
mean. Right,
Min.
very good. This will get the minimum or the least age on this attribute. How about the last one, letter D? Who is the youngest player? How old? Sorry, how old is the youngest player? Okay, so age is equal to mean. This one is minimum. Yeah, returns the smallest. Who is the youngest? This one is who. All right. So who is the youngest player?
Now we age equals.
What?
Do we have age equals to mean and name? I don't know. That's correct.
Age is equal to mean. Yeah, that's correct. But
And
we
name
have to use another condition, and then
and
just use the word and then you can now put another condition. And
name.
name.
I don't. I don't know. You do equals to here.
Name. So what is that will project? So once for computation, turns to frequency. Hmm. Select player name. All right, so let's go back. Name is equal to Costa. Name is less than. Hmm. So how will we display the name only? because in here I have another way of doing this one, but I haven't introduced it yet, which is the project. Okay. So anyway, I'll just use project it here, and then I'll just explain it to you guys later on. So if you're going to use the word project, so basically it is the same, but we'll use double selection instead. So we have project here. So supposedly this one is a pi symbol, okay, pi symbol, and then close and open parenthesis. So the same, we have here the inside, which is the select format. So select layer, and then age is equal to mean, and then it will stay as it is. But then I will only display the attributes. So since this one is project, so we have to indicate the attributes that we're going to display. So in here, we only need to display the name. All right. So with the use of project and select, so we will be able to display the name only, wherein we have the minimum age inside of that table. All right. So this is the answer for the letter B. Right. So who is the youngest player? So first, it will find the minimum age under that table, and then it will only display the word or the attribute name. All right. So did you guys get it so far?
Yes, sir.
Yes, sir.
All right. So for now, let's have more examples about select uh, attribute. Okay. So later on, we'll be having more examples about project. All right. So let's have these examples. So display the sum of all amounts transacted to account number 1, 2, 3, 4. Okay. But before you answer those, so you have to know that we have this table customer, table history cost, table credit card, table merchant, and then table charge. All right. So we have 4 tables, and then we have these 3 questions. Okay. And then of course they have their own attributes. So attributes of this one is customer ID, C name, C address, and so on and so forth. All right. So first question here is display the sum of all amounts transacted to account number 1, 2, 3, 4. Anyone wants to volunteer in answering number 1? Display the sum of all amounts transacted to account number 1, 2, 3, 4. So as you can see right here, account number is an attribute under credit card. Okay, so it could be under charge or credit card, but since we're talking about the the sum of amounts, okay, so it should be under credit card. Okay, this one is a different table when it comes to this one. All right, so from here, you could say select, and then the table name, which is credit card, followed by the condition. Is that close it up in parenthesis? I know. So just a bracket. Okay. So bracket, and then your condition here is account number is equal to 1, 2, 3, 4. Okay. And account number, and account number, yeah. Account number is equal to sum. Sorry. Okay. So the total amount is in here. Okay. So I was looking for the word amount a while ago, but instead of amount, it's total amount. Okay. So yeah. So it's not under credit card, but it's under charge. Okay. My apologies on that one. So we'll change the table name into charge, and then account number is 1, 2, 3, 4, and then tot amount is equal to sum. All right. So did you guys get this one so far? For the number one?
Yes, sir.
How about the others?
Yes.
So you can you can interchange those two. So you can get put this one first. Put thought amount is equal to sum, and account number is 1, 2, 3, 4. So it doesn't matter. So arrangement here is not that important. All right. So for number two, what is the minimum credit limit given to a customer? Credit limit.
Select credit card.
Okay. Under credit card. So select credit card, and then what is your condition?
Sir, credit limit equals minimum.
Credit
Yeah.
limit is equal to minimum. Okay, so that way you'll be able to get the minimum credit limit that is given to customer. All right. How about number three? How many credit cards that were open today? So
Select credit card.
so let me change this one. How many
Yeah.
credit cards that were officially registered? Okay, instead of open today. Okay, because this one is quite ambiguous since we don't know if it's still open up until now or they are already closed credit cards. So in here, how many credit cards that were registered under a certain system? Okay. So
Select
select
credit card.
credit card, and then your condition.
Dates opened.
Hmm?
Dates opened.
Date open. And
That
then
should be equals to
what
count.
equals count. Yeah. So basically, you can just simply count the date open of that credit card, or you can do this one also. So account number is equal to count. Okay, since I have already revised this question. All right. Last example, what is the average credit limit of all the credit cards used by customer ID 25? Anyone?
Select credit card.
Mm-hmm.
Select credit card.
And
Credit
credit card.
limits.
And then
Credit limits
credit limit
equals to average,
equals to average.
and customer ID equals to 25.
All right, very good. Okay, so this how you answer 1, 2, 3 for examples. Okay, so just take a screenshot of this one since I won't be able to put it on your module anymore. All right, so that's it for select. So any questions so far regarding with select operator?
Wala naman po, sir.
All right, so let's now move on to the next one, which is projection operator. So it symbolizes this one, or the symbol for projection is pi. Okay, so this one selects columns in the table with duplicates eliminated. So take note when we say duplicates eliminated, so it will just basically eliminate the same tuples. Okay? Like for example, they have the same elements of this tuple and then this tuple, and it will eliminate those once you have used this operator. All right, so we have the syntax, so actually quite the same. So we have this operator, and then the name of the table, and then your conditions, okay, or operations. And then for the last one, you're going to indicate here the columns that you're going to display. All right, so we have here the condition. So project player table, and then the attribute name, and then the attribute position. So as you can see, it displays the entire column of that name and then the entire column of that position. All right. So as simple as that. So did you guys understand this one?
Yes, sir.
All right. So if you want to display everything, then you have to indicate everything in here. So name, position, ID number, and then age. Right. All right. So let's move to the next one. So find the output of the following commands. So we have the same table, but we have here a combination of a project and then select. So this is what we have used a while ago. So we have the project and then select. Okay. And then take note, the select condition is inside of close and open parentheses, right? So meaning it will call this one, initiate this one first, and then followed by this project, and then the choices of the columns under this condition. All right, so we have this format wherein select layer age is greater than or equal to 30. So basically, you have to find first what are those tuples wherein age is greater or equal to 30. So you can see we have two tuples for this condition. So the Costa and then Hontiveros. And then once you're done with that, so it will only display under the projection name and then age. Okay, so the name and then age only. So Costa is 30 and then Hontiveros is 37. Right? So did you guys get this one so far for letter A?
Yes, sir.
All right.
Yes, sir.
So we have another example here wherein it is using two condition. So position is equal to P and then age is greater than 30. So basically, we'll just find the position wherein it's equal to P. So we have two. But then we have another condition wherein age should be greater than 30. So as you can see, there's only one tuple that has that uh, result wherein with those two conditions. So Hantiveros is equal to 37. And then uh, here you're only choosing the attributes or columns that you're going to show. Okay, so in here you're going to show the name, you're going to show the position, you're going to show the age. Okay, so name, position, and then the age. All right. So understood so far?
Yes,
Yes,
sir.
sir.
All right. So if you guys have a question, feel free to ask me anytime. All right. Next one here is join operator. So basically, you just combine two tables. Okay, it's as simple as that. But then we have this condition wherein before you can combine two tables, you need to find the similar attributes between the two. Wherein, as always, okay, the case when it comes to combining two tables, they must be equal in terms of key. Okay, so in here, our key here is the ID number, and then the key here is the PID. And if you're going to take a look on the PID and ID number, their tuples value are the same with this one. Okay, so 22012, we have that one here, 22012. 93831, we also have 93831 in here. Okay, so that's our minimum condition when it comes to combining two tables. If you don't have that condition, then you won't be able to combine a certain table. Okay, so at least you have that one for you to be able to combine two tables. Okay, so we have the syntax, the name of the table one, and then the name of the second table. All right, and then this link attribute is where they are equal with each other. So this is very important. If you won't be able to find any link attribute wherein they are equal with each other, then you won't be able to combine a certain tables. Okay, and then we have this symbol or symbol operator for join. Okay, so it's like absolute or cardinality of x. Okay, x here means you're going to join two tables. All right, so as you can see right here, we want to combine or join the table player, which is this one, and then the link attributes. So as you can see, they are equal in terms of ID number and then PID, and then the name of this table is assignment. All right, so as you can see, they are now combined with each other, side by side. All right. And one more thing, whichever is the first table, that is the format that we're going to follow. Like for example, the format for the first table is 22012, 93831, and so on and so forth. So it will go along with this table. So 22012 first, and then 93831 for the second, and then 58199 for the third one, and so on and so forth. All right. So did you guys understand this one so far?
Yes, sir.
How about the others?
Yes, sir.
Yes, sir.
All right. So as usual, we don't have a time anymore. So I will stop here for now and then just wait for the part two. Okay. So we will continue the rest on part two. All right. So goodbye and see you guys on part two.
Okay, sir.
Yes, sir.
All right. So it seems that most of you are here already. So do you guys have a question so far before we'll continue our discussion?
Wala naman po, sir.
Sir, I want to ask the empty row in between. Is it telling us that it's listed all the attributes down to the last one?
Pardon? This one?
Like, yeah, this one. For the table we have below, we have ID number, then we have the first row, then we have an empty row, then we have the third row. I mean, the two dot is it telling us it listed all the elements down to the last one, or it
Yes,
only
yes, yes.
listed it?
So
Okay,
basically we have 10 tuples. No,
okay,
sorry. We have 5 tuples only. Okay. So
five, yeah,
from here to here, and then followed by this table, wherein the format that this one is following, the PID, is the format of your ID number. So as you can see right
okay,
here, 22012 and then 180, which the same with your ID number. Okay. So this one is now interchange or change to this format. Did I answer your question, Mr. Followewo?
yes, sir.
Okay, so since there's not enough space, so we've only shown here the dot, okay, meaning we've shown up to the second, up to the last tuple. So as you guys may know already, we have a total of 66 slides for this module. So I'm afraid we won't be able to finish everything for this module number 5. So I don't know. So whatever the topics that will be finished up to the part 3 or part 4, so that depends. Then that's it. Then we'll just continue the rest next meeting. All right. So let's have an example or an exercise rather, not an example. So consider exercise for the following tables. So we have 4 tables. We have employee, we have buyer, department, and then supplier. Then of course they have their own uh, attributes and tuples. All right. So here are the questions. Number 1, find the names of all employees. So do not include any managers. So anyone who wants to answer number 1, find the names of all employees. Do not include any managers. So just the name of the employee. All right. So I will answer number 1. Project. So once you see this one, okay, do not include any managers. So meaning we're now excluding some of the attributes. So if we are excluding some of the managers, then you have to use the project operator, okay, instead of the select operator. Okay, so from here, just project the table employee since that is the question, and then the attribute name only. Right, so in that case, you're now showing the column of this table, which is name only. Okay. And yeah, forgot. So do not include any managers. So maybe you can include here the ID number and the name only, since the only limitation is you should not include manager, or exception is manager. Right? Anyway, to be more exact, I'll only display the name. Okay, so that is the answer for number 1. How about number 2? Find the names of all managers, filter only names of managers. Okay, so how will we answer that one?
We get
So
employee
we have here
managers.
the attributes, so that will not be going back to here anymore. So we have the attributes of employee, ID, and then name, and then manager. Okay, so anyone who wants to answer number 2?
We get the department manager. Can you start also?
Employee, and then
Can we use department manager also?
department manager.
We
Find the
just
names
department.
of all
Then,
managers.
yeah, since we
Filter
have it on
only
that.
names of managers. All right, so let's see. So you can use department table or use department, no, sorry, table employee. Okay, so as you can see, we have a lot of managers here, but in total, they are just the same. Okay, since the duplicated names of the manager will be eliminated. Okay, going back to here, where is that one? Projection. So it's here. It says here for the projection operator, uh, duplicates will be eliminated. Okay, so you can answer the employee or the department. Okay. So either of those two. So you can have that, or you can have this one. Department, and then manager. There you go. All right. So those are possible answers for number 2. How about number 3? Anyone? Find all part numbers. Filter only part numbers. So if you're going to take a look at this one, we have 2 part numbers. So part number for buyer and then part number for supplier. But in here, you have to take a look on the table now. Okay. Since this one is much more complete, I guess. 335 to a yeah, this one is much more complete than this one, since this one has the 772 table or element, but in here we don't have that one. Okay, so the question here is find all the part numbers, so we have to indicate everything, or yeah, that's the only possible answer. So there's no or, sorry. So in here, project from what table name?
Supplier.
Supplier, and
Part number.
part number. So as simple as that, right? So we have a continuation. So 4, 5, 6. So 4, find all names of buyers. So filter only names only. Anyone who wants to answer number 4?
Reject buyer.
Project buyer
Name.
Right. How about number 5? Find the names of all employees who are managed by Bote.
Reject employee.
Employee
Name.
And then,
and
pardon?
wait, we have to, can we use select here?
Yes, yes, yes. So you got it. So we have to use project and select at the same time. Okay, so let me give you guys the format. So after this project, we have this select, followed by the table name. So what is the name of the table?
Employed.
Employee.
Employed.
Followed by the condition.
Manager.
Manager.
Equals bote.
Equals to bote. Okay. So Mr. Agustin already answered that one for you, Mr. Polobewo. And then, what is the last one? So in here, we will only project the name of that
employee.
So as you can see right here, we have to initiate this one first. Wherein we're going to look for the tuples wherein manager is equal to bote. Then once we're done with that, then we will only display the name of under the manager is equal to bote. Since the requirement here, find the names of all employees who are managed by bote. Okay. So the only one that will be project is name under manager bote. All right. How about number 6? Find the part number being managed by Pablo. Filter only manager and part number. So let's go back to the table. So find the, what is that? Find the part number being managed by Pablo. So part number that is being managed by Pablo. So from here, we have the manager, wherein it has a department of 66. And then if you're going to take a look at this one, 66 department is part number 42. So the question here is, we have to project the manager and part number only, okay? So actually it is coming from 2 tables. So what will we do? Anyone who has an idea? All right, so I guess none. So the first thing that you need to do when it's asking you to project 2 attributes that is coming from 2 tables, so there's a big chance that you can combine those 2 tables to come up with 1 table only, okay? Because we cannot select and project 2 tables at the same time. So we can only select and project 1 table, okay? So from here, we have to join the department and supplier first. So where is that? No, we don't have the format for join. Anyway, so we have this format, so X, and then the name of the first table. We have here department, and the link attributes wherein they are common with each other. So as you can see, they are common in terms of department. So department is equal to department, followed by the name of the second table, supplier. Supplier. All right. So once you're done in combining those two, so of course, it will give you a new name. So let's just say that the new name of that table is department supplier. All right. So from there, you could use now the project, followed by the select, and then the name of that table. So I'll just assume that the name of that new table is a combination of those two. So department supplier, and followed by the condition. So what is the condition? So find the part number being managed by Pablo. So part number is equal to Pablo, or manager is equal to Pablo. Yeah. Manager is equal to Pablo. And yeah, that's it. And for the last one, we have to project to the part number and the managers. This is correct. Filter only manager and part number. So there you go. So here's the answer for the number 6. So first we combine them, and then from the combined tables, then we can now do this condition. So manager is equal to Pablo. Then once you're done in looking for that tuples, then we will only display the part number under manager Pablo and then the name of that manager. Right? Did you guys understand number 6?
Yes.
Is there anyone who's confused? All right, so guess none. So it's maybe 100% yes that you're confused, or 100% no that you're not confused. Anyway, so if ever that you have a question or clarification, so feel free to message me anytime to my Canvas account or my Facebook account. All right. So if you guys do not have a question regarding with this exercise, then you may now start and answering seatwork number 1. Okay, so we have 5 questions that is coming from this table. So basically the same table, but just a different question. All right, so you can answer this one using Microsoft Word and or handwritten. Okay, so if you're going to do this one handwritten, please write legibly. Right. So any questions so far regarding with your seat break number 1? So do not analyze it for now. Okay, since you will not last long for this slide. So just ask me later on, okay, once you're now answering or starting to answer this sit work number 1, right? So basically the same concept, and then this is work people. All right, so that's it for your sit break number 1. So let's move on to the next one, since again, we're limited when it comes to time. So the next one here is union operator. So this one is very similar with the topics that we have discussed before. When say union, we will basically combine 2 tables, okay, but not side by side. So in here we will combine them, okay, vertically or by column or by attributes. So you can only combine or you can only use the union operator if they have the same attributes. Okay, so they must have the same attributes. If they don't have the same attributes, then you won't be able to union them. Okay, so as you can see right here, we have this syntax R1 union R2. So R1 is representing the first table, and then R2 is representing the second table. So for example, we have teach M. This is your first table, and then union non-teach M. This is the second table. So of course, first table first, followed by the second table, right? And then at the same time, it has this function wherein it will remove the duplicates. So if ever we have duplicates from this second table to this first table, then it will be removed by this operator. Right, so did you guys get this one so far for union? Hello? Are you guys still there?
Yes, sir.
Yes, sir.
All right. So did you guys get this one or no?
Gets naman po, sir.
Yes, sir.
You guys sure? Seems that you guys are not listening. Anyway, so again, if you have a question, so feel free to ask me anytime. So that's it for union operator. Okay, so they will be combined by attributes. Then we have here intersection operator. So same concept, they must have the same attributes. And then as you can see, when you see intersection, you will only get, okay, or we are only getting the common tuples between those two tables. So let's say we have R1 intersection R2, so teach M intersection non-teach M. So of course, it will only get, or it will only display the common tuples or the same elements of tuples. So as you can see right here, we only have two, which is this Aquino and then Clara. Okay, 20,000 and then 10,000 ID number. Right, and then the rest will be removed. Right, so understand so far?
Yes, sir. Nugget naman po.
Yes, sir.
Next one is difference operator. So in difference operator, arrangement does matter in here. Okay. So you could have R1 minus R2 or R2 minus R1. Okay. So whichever is the first element, I mean, first table, that is the one that will be retained. Okay. And of course, the same condition wherein they must have the same attributes before you can use this difference operator. So we have two examples here. So teach M minus non-teach M. So we will retain the first one and then we'll remove the or their common tuples. Okay. As you can see right here, the commonalities is Aquino and Clara, or 10,000 and then 20,000 from the second table. So we have to remove those two on this table. Okay. So we will retain Acosta, Costa, and then Fontiveros. Just remove the common tuples. All right. And if we have this format wherein non-teach M first versus minus teach M, okay, then we will retain the second table and then we'll remove the first table that is common with your, or the common that is top, that wherein the tuples from this table is common with this table. Okay, so as you can see, again, they have commons when it comes to Clara and Aquino. So we'll remove those two and then retain De La Cruz, Rizal, and then Bonifacio, which is now this one. All right. So did you guys understand this one so far?
Yes, sir.
Can you guys still follow? Or
Yes,
are you
sir.
guys confused now?
Yes, sir. Nugget naman po.
Get some man. Okay. How about you, Mr. Folawewa?
Yes, sir. Understand.
Mr. Mendoza? Right, so I guess he's not here. Mr. Agustin?
Yes, sir. Po.
All right, Mr. Gangas? I think said something, but I wasn't able to hear it. Anyway, Miss Sekligan, narinig ka na. Okay daw. Miss Sekligan? Yes po, sir. Okay. Miss Rona? All right, so I guess Miss Rona is not here. Mr. Tanikala?
Yes, sir.
Okay, Miss Tandok?
Yes, sir.
Okay, Mr. Estadilla?
Yes, sir.
Miss Ginoran?
Gets po.
Okay, Mr. Paran?
Gets naman po, sir.
And then Mr. Vicente.
Yes, sir.
All right, so I think you speak, but I wasn't able to hear. Anyway, so actually, I'm just checking if you guys are really there or no, because you know, a lot of my students, or most of my students, especially if it's a big class, so like 30, so 10 of them are not really responding, meaning they are not around. So they just joined the Zoom meeting and then did something else. Anyway, so it's a good thing that you guys are here. So the next one here is functions. So basically, when we say functions, we have this pre-image and then this image. Okay, so it is composed of two different columns. So the pre-image is the before, and then the image is the new value of that pre-image now. So when we say pre-image, we have this function. Okay, that is why we call it function. Wherein in every function it has a corresponding formula. Wherein in here the formula for f of x or for this function is x squared. And then as you can see, the pre-image of 4 became 16. So you could see when we say function, it is forming a new value out of that function. Okay, so this is a special kind of relation wherein this pre-image is always related with your image. Okay, so it takes an element from a set and maps it to a unique element in another set. So this set is basically the same with the second set. So how did we arrive this with this second set? This one was derived from the first set with the use of a function, and that function that we're talking about is for a certain formula. So that depends on the formula, right? So as usual, we have this domain and then co-domain. Okay. All right. So let's move on to the example when it comes to functions. So we have the domain and then co-domain, or the x or the y. Okay. So we have Alice, Bob, Chris, Steve, and then Emma, wherein they are related with your co-domain. So Alice is related with A, Bob is C, Chris is A, Dave is F, and then Emma is D. Okay, so as you can see, this one is a class grade function. Okay, so what is the grade of Alice? So there are some questions wherein something like this. What is the grade of Alice? So the grade of Alice is A. What is the grade of Chris? So the grade of Chris is A, and so on and so forth. And then we also have this question: what is the, or who has the grade of C? Okay, or what is the pre-image of C? So as you can see, we have Bob. So another example, who is the pre-image of letter A? We are grade of A. So we have Chris and Alice. So, simple questions that can be answered by a function. So we have here a string length function wherein this is the pre-image and then the image. So this one has one string. This one has two string, 4, 2, and then 1. All right, so basically this one is just a representation wherein in relation of string length, okay, or the count of strings. All right, so let's have basic terms. So whatever is the first one, or whatever is your domain, that is always your pre-image. Okay? Whatever is the second one, that is your image or range. Right? So as usual, your domain is X, and then your codomain is your Y. So just like what I have said a while ago, so the image of f Alice or function Alice is A. So meaning this one is, what is the grade of Alice? So A. And then pre-image of C is Bob, right here, means who got the C grade, which is Bob. All right, so those are like, kind of dumb questions or dumb analysis. Anyway, that is how we read a function, or that's how we interpret a function. All right, and here are the properties of a function. So a function f is always going or coming from x going to y. Okay, so it is a relation from x to y. Okay, so do not interchange those two. When we say x to y, x first followed by y. So y to x is a different function anymore. Okay, or function already. Okay, so we have two properties for us to be able to say that this one is a valid function. So first property here is the domain of f is x. So as always, it should be the domain, okay, or your pre-image, which is your x. And then it has one directed edge for every domain, meaning we cannot have two direction for your domains. Okay, so we'll be having an example later on. But for now, let's use this simple example. We have this function 1, wherein it has a relation of 1a, 2b, and then 3a from the coordinates 1, 2, 3, and then ab. So whichever is the first one, that is your domain, okay, or pre-image, which is 1, 2, 3, and then the second one here is AB, which is your codomain. So it says here it is a valid function because the domain of F1 is 1, 2, 3. Okay, so this is your X, and then it only has one directed edge of every pre-image. So meaning all of your domains has a partner, and then it only has one directed edge that is going to your pre-image. Okay, so later on we'll discuss more what is this one directed edge only. All right, so this is now an example of not a valid function. So as you can see, we have this function 1A2A3B, and then these orders 1, 2, 3, 4, 1, 2, 3, 4, and then ABC, and then ABC right here. So this one here is not a valid function because the domain of f of 2 or function 2 is 1, 2, 3 only, which is again not equal to your x since your x is originally 1, 2, 3, 4. And as you can see right here, your 4 doesn't have a directed edge on the pre-image. So when we see a valid function, okay, all of your domains must have a partner, okay? But then again, it should be only one, okay? So one domain should have only one partner, and of course, it must have a partner, okay? That's what is one? This is terminology for that one. That is a requirement or that is mandatory, okay? So if one of those is not met, then that one is not a function anymore, okay? Like for example, imagine that this one is the list of students. So number 1 has a grade of A, number 2 has a grade of B, number 3 has a grade of B. But number 4 doesn't have a grade, wherein in a class, it is not valid. So he or she should have a grade, whatever happens. Like if he's failing the class, then you should, or this one should have a grade of F, okay, or a grade of 72 or 73, okay. Wherein in this scenario, he doesn't have a grade, so this one is not valid anymore, okay, since that one is illegal, okay. So not actually illegal, but that is a requirement for us instructors to give you guys a grade no matter what happened, right? So did you guys get so far? And how did we come up with this example for not being a valid function?
Yes, sir.
How about the others?
Yes, sir.
Yes, sir.
Yes, sir. Okay, very good. Okay, so let's have more example. We have example number 3. We have 1A, 2B, 3C, and then 1B. So we have partnerings from 1 to 3 and then A, B, C for your Y. Okay, so this one again is not a valid function because if we're going to relate it again to a student and then to its grade, so it's like we're saying that this student number 1 has a grade of letter A and B at the same time. Like he has a grade of 90 and then 85 at the same time. So he has 2 grades, wherein you don't have that one in real life. Okay, so this one is not a valid function anymore. Okay, so yeah, that is the reason why we must only have one directed edge coming from your pre-image. I mean image, then going to your coming from your pre-image and then going to your image. All right. So did you guys get this one, number 3?
Yes, sir.
Yes, sir.
Okay. So I'll only give you guys 2 requirements when it comes to a valid function. So all of your domains must have a partner, and those domains must only have one partner. Okay. So in image or codomain, so they can have as many partner as they can have, and yeah, they can have as many directed edge as they can have, but for the domain, they cannot, right? So once you're getting understanding about function, then you guys may know answer seat break number 2. So this one is super easy. just need to tell whether it is a valid function or not. So just do this one using a Microsoft Word. So just put there 1, 2, 3, 4, and then upload it to Canvas. Okay. So 1, 2, 3, and then 4. All right. So are we clear so far for your secret number 2?
Yes, sir.
Are you guys still there? Anyway, so let's
Sure.
move to
Yes,
the
sir.
next one. All right. So we have here the vertical test for a function. So this one is just a representation of a graph wherein if the vertical line cuts the graph of a relation in more than one point, then the relation does not represent a function. Okay. So you just imagine that those curves are coordinates that is formed from a relation. Okay. So you might have 5, 0, 7, 1, 8, 3, and so on and so forth. So those are coordinates. And it says here that if you're going to do a vertical test, let's say this vertical test here, and if it hits one or more than one point, then this function is not a valid function anymore. Okay? So as you can see, this one is not a valid function, and this one is a function. Okay, since wasn't able to hit one more point for this coordinates. All right. So yeah, how about this exercise? Okay, so let's see whether you guys have really understand the vertical test for a function. Is this a function? This graph?
Yes, sir.
Yes, sir.
Yes, sir.
How about this one?
Yes, sir.
Yes, sir.
How about this one?
No.
No. No,
No.
sir.
How about this one?
Yes, sir.
How about this one?
No, sir.
No.
How about this one?
No, sir.
No, sir.
How about this one?
Oh, sir.
No.
And this one? All right.
No,
No.
sir.
Okay. So just a quick discussion when it comes to vertical test or a function. All right. So writing a function. So we have this given relations. So A1, E2, E4, and so on and so forth. So the diagram can be written as function. So f of A is equal to 1. F of E is equal to 4. F of I is equal to 5. And then F of O is equal to 2. All right. So basically, we're just representing this image to this image, wherein this function has a value of 1, etc., etc. All right. And then we have here algebra of. All right. So my apologies on that one. I wasn't able to monitor the time anymore. Anyway, so I guess you guys are already here. Yeah, 14 participants. So how many are we on part 2? I think we were 15.
15.
15, right? So there's still one student who's not here. Anyway, so we'll wait 1 more minute for him or her. So yeah. Right. So I guess this is not going to join us anymore. Anyway, if ever that he or she is going to join us, then he'll just catch up to us. All right, so we have this algebra functions, which is super simple. That is already maybe discussed with your algebra. So we have this function f plus g, or function plus another function is multiplied to your x So your x here is the f of x, and then your another x here is your g of x. So it's like using the FOIL method, or like distributing this x to this f and then this x to this another function. All right, so that's how we've got this formula, f of x plus g of x. All right, so we cannot see this one is function, but anyway, this one is another function. So this is function number 1, and then this is function number 2. Okay, so let's just say that this one is function 1, function 2. So that's how you add them using this formula. Okay, and then we have another algebra function here wherein it's representing the difference, or minus. You have f minus d, so similar with this first format, just different operator. So f of x minus g of x, right? And we also have this FOIL multiplication, so it's like same method, FOIL method. So f times x times g of x, right? And then we have this division. So we have this f of x divided by g of x, where g of x should not be equal to 0. Why? Because again, if you're going to solve that one on the calculator, you'll get a math error. Okay, so your g of x should be less than negative 1 or greater than positive 1. Okay, so it could be equal to negative 1 and above, or less than, or 1 or equal to 1 and above. All right, anyway, as long as it's not 0. All right, so did you guys get this one so far? Algebra of functions.
Yes, sir. Get naman po.
Yes, sir.
All right, so let's have some super basic examples. You have here the function 1, wherein it has a formula of 2x, and then another function wherein we could say this one is g of x, but in here it's just using the f of 2x. All right, so f of 1, f of 2, function 1, function 2, wherein this function 2 is equal to x squared. So if you're going to use the addition algebra, so f of 1 plus f of 2 times x. So if we're going to answer this one by one, so f of 1 times x plus f of 2 times x, wherein f of 1x is 2x plus f of 2x is x squared. Okay. So that's it. That is already your answer, since we cannot simplify this one anymore. All right. So this is the answer for letter A. Did you guys get this one?
Yes, sir.
Yes, sir.
All right. Let's now answer letter B. So we have multiplication, so same concept, just different operators. So f of 1 times f of 2. Okay. There you go. So instead of plus, we'll use multiplication. 2x times x squared. So in here, you can still simplify this one, wherein you will get 2x cubed. Correct? Hello, guys.
Yes, sir.
Yes, sir.
Keep fighting. Okay, we're almost done. I mean, not yet, but we're almost done with our meeting for today. Okay? So I guess we're not really be able to finish this one since we're still at half slides. Anyway, so let's now move on to the so no more examples. So this is your seat break number 3. So yeah, super easy. All to do is get this function and then this function and then apply it to this algebra. Okay, algebra function. And then this function, and then to this algebra. Okay, and then simplify it to its simplest form. All right. So we have that one for 1, 2, 3, and then we have this one for number 4, wherein it has 4 different functions or algebra functions. Okay, so we have this function number 1 and then function number 2. Okay, and then put it here and then simplify it to its simplest form. All right. So again, you guys can answer this one in Microsoft Word or you can do this one handwritten. Then again, if you're going to do this one handwritten, please write legibly. Right? So are we clear so far?
Yes, sir.
Sir.
Yes, sir.
Okay. So recall your algebra. Okay. So this is where you will apply your long solutions in algebra. All right. So we have here graph of a function. So we have this function and then its graph. Okay. So this function 2x plus 1 is forming this graph. And then those blue labels are just an indicator wherein this one is 3, this one is 5. And as you can see, this one is our codomain or range. Wherein, actually, this one is your y. F of x is equal to your y. So that is why I put here y is equal to f of x. Okay. And then, what will be the line that will form if we have a value of, let's say, -1, +1 for your x. So as I can write here, if we have -4, our y here is -7, wherein we have -4 for your x-axis. We have -3, we have -5. We have -2, we have -3. We have -1, we have, oops, -1 is -1. So this one is incorrect. So correction, -1, -1. All right. And if we have 1, we have 3. If we have 2, we have 5. And then if we have 3, we have 7. So as you can see, this one is a valid function or a legitimate function, since if you're going to apply the vertical test, you won't be able to hit one more coordinate. All right. So did you guys get this one so far?
Yes, sir.
Okay, so again, this fx is your y. So this is your x-axis, y-axis. And then it's form curvature. So this one is actually not curved, but this one is diagonal. Anyway, so yeah, simple as that. And then here's your seat break number 4. So all to do is do the same like this one. So you can do this one in Microsoft Word, okay, or you can do this one handwritten. Okay, if you're not familiar in using the graph in Microsoft Word, right? All right. So next one here is one-to-one function. So this one is super easy. So a function from x to y is said to be one-to-one if for each y is an element of y, there is at most one x is an element of x with f of x is equal to y. So as you can see, we should only have one x and then one y. So as you can see, this one is a one-to-one function. So this domain has one directed edge, one directed edge, one directed edge, one directed edge. So this one is a one-to-one function. Okay. So what's important here? All of your domains must have a partner for you to be able to see that it's a one-to-one function, and then all of them should only have one partner. So nevertheless, for uh, the codomain or range, so it doesn't matter if there's one that doesn't have a partner. So there can be unused elements in the codomain. So that's okay. This one is still a one-to-one function. So what we're worried about is the domain. And as you can see right here, this one is not a one-to-one function anymore, since we have 2y, yeah, we have 2x now for your 1y. Okay. And in here, in one-to-one function, so 1x only followed by 1y. Okay. Wherein in here we have 2x followed by 1y. So that is why this one is not a one-to-one function. This one is a valid function, but not a one-to-one function. All right. Did you guys get this one so far?
Sir.
You guys sure? So feel free to ask me anytime if there is a part that you guys didn't understand, right? And yeah, that's it for one-to-one function. Super simple, super basic. So once you're done with that, so you may now start answering seat work number 5, right? So tell which function is a one-to-one function and which is not. All right. So we also have onto function, wherein if f is a function from x to y and range of f is y, f is said to be onto y. Or if every element in the codomain is an image of some pre-image, then that one is also onto function. So as you can see right here, we have this domain and then this codomain, and then all of them has a partner. If that's the case, that one is an onto function. Okay. If there is at least one on the codomain that doesn't have a partner, like this one is not an onto function anymore. Well, this one is a valid function, but not a valid onto function. Right? Because we have 3 and 4 that doesn't have a partner. Right? So did you guys get this one?
Yes, sir.
You guys sure? How about the others? Alright, so I
Yes, sir,
guess
gets both.
parang inaantok ka pa rin, Mr. Agustin, ha? Anong oras
Hindi na
natulog?
po, sir.
Anyway, so of course, once you're done with this topic, of course, we're going to have a super. Okay, so this one is super easy again. So which of the following functions are onto, one-to-one, both, or neither, right? So we also have bijections, wherein consider a function that is both one-to-one and onto at the same time. So from the word bi, so it must be one-to-one and then onto. So both of those functions must be met for us to be able to say that, all right, that one is a bijection. Okay. So since right here, this is an example of one-to-one and then onto. So checking this one by onto function is super simple. All of them must have a partner, okay, x and then your y. And if it's one-to-one, all of your domains and then range must have only one partner. If that's the case, then that one is one-to-one. And then as you can see, this one is one-to-one and onto, then this one is a bijection. All right? Understood?
Yes, sir.
Yes, sir.
All right, let's now move on to the next one. So we have here identity function. So it is a function such that the image and the pre-image are always equal. So if we have this kind of, say, happenings or coincidence, if your x is always equal with your y, then this one is identity function. Or this function is equal with this function, and this one is identity function. All right? So as simple as that. So no matter what is the value of your x, you still have the same value, okay, from your pre-image to your image. Okay, we also have here the inverse function, wherein your x will become y, your y will become x. So a bijection whose function is from y to x, okay? So that is why it's called inverse, because supposedly this one is from x to y, but in inverse, it's the opposite. It's now from y to x, okay? So we have this example, f of a is equal to b, and if you're going to do the inverse of this one, your inverse function will be will interchange. Okay, so here now is your function, which is your b, and then it is now equal to your a. So basically, your image or pre-image become your image, and then your image become your pre-image, vice versa. Okay, to go back to its original function. So we have those two property. So we have this one f, and then multiplied to inverse function of x is equal to x. Or we can have this simpler formula. So inverse function of f is equal to x. So mostly this is the one that you're going to use, since this one is much more lesser or intact rather than this one, which is quite longer. So yeah, that's it for the inverse function. So again, your x become your y become your x. So let's have an example. Find the inverse of the function. So anyone who wants to volunteer to answer this example? So your f raised to negative 1 is equal to 1. Right, so I guess no one likes to volunteer. So I'm guessing that your brains are super exhausted now, due to overload of knowledge, due to overload of topics, maybe. Not really knowledge, maybe. Yeah, information or knowledge, but due to exhaustion, then you won't be able to call this one absorb, okay, the information that we are now discussing right now. Anyway, just do a lot of self-study. Okay, so we're discussing all of them one by one in a fast pace, since we're very limited when it comes to time. Okay, so my apologies on that one. Anyway, so the answer for this one here is, again, when it's the inverse of function, your x will become your y will become your x. So the inverse of this one is a1, c2, and then all right, so as simple as that. So Mr. Tanikala actually answered this one, so he sent a direct message to me, so which is the same with this one. No, okay, so your 3b is incorrect. So this one should be b3, right? Okay, so I really appreciate your response, guys. So that's because one that only means that you guys are really listening to my discussion, and that only means that you guys are really interested with this subject, right? Anyway, so let's move on to the example number 2. So we have this function f of x is equal to 2 times x. Okay, so using this formula, we have actually 3 steps or 4 steps that needs to be done. Okay, so your f of x will be replaced by y. Okay, since initially this one is really y, like what I mentioned on the graph. Okay, f of x is equal to y. Where is it now? Here. And then this original format will be interchanged. Okay, so your x will become your y will become your x. Okay, so as you can see right here. And then the one that we are looking for is the value of your y. So solve for y and simplify. So in here, just transpose this 2 over here. Then you will get y is equal to x divided by 2. And then going back to the original formula, so y is the inverse function of x, which is now equal to x divided by 2. Okay, so this is now your answer. All right, so this is the inverse function of this original function. Okay, so from 2 times x became 2 times x became x divided by 2. And then you can check this one, of course, wherein you will come up with the original formula. So this f or inverse function of x is equal to x divided by 2, which is now this one. And then this x is your, where is this one? 2. 2. And then this is came from your final result, which is x divided by 2. And then if ever you're going to simplify this one, okay, you will have equal to x. So as you can see, this is the inverse function, and then this one goes back to this x. Anyway, so this is just a way of checking whether your answer is really correct or not. But if you're sure that you have done those steps, then 99% of your answer will be correct. All right, so let's have another example here. So find the inverse function of f of x is equal to 2 raised to x. So in here, we actually have two solutions. So for solution A, we have used the log, and then for solution B, we have used the log. So we have this original, okay, formula, y is equal to f of x is equal to 2x, or just y is equal to 2 raised to x. Then of course, the second step is interchange those two. So your y will become x, your x will become y. And then from there, you can now use the log, okay, to bring down this y here. So log of 2, so this is your base, and then log of 2 of x is equal to the exponent, which is your y. And then from there, we now have the value of y, log of 2 of x. All right. So we have another solution, which is just the same, okay, but just a different way of doing it. So in here, we're going to use ln. So y is equal to 2 raised to x, and then interchange those two. So x became y became x. And then just multiply both sides by ln. And then in applying ln, so you can actually bring down the exponent here. So supposedly we have 1 here, 1 times ln of x, but since it's only 1 and it's multiplication, so you can just remove that 1. Okay, nothing will change. And then in here, we have an exponent of y, so just bring down this y on the other side. So y times ln of 2. And from there, we can now simplify this 1. So divide both sides by ln of 2, then you will get this kind of expression. So y is equal to ln of x divided by ln of 2. Okay, so if you're going to like say, like for example, it has a value for your x, and then this one has a value for x, you will have, or you will get the same answer. Okay, so just two different solutions, but the same answer. Okay, so we have this y, this one is correct, this one is also correct. All right. So were you guys able to follow so far?
Yes, sir.
All right, so maybe I'm assuming that maybe we're able to follow, but maybe most of you were not, since we're not really using log and then ln in our equation. So if you're not familiar with log and then ln, so feel free to research this one on YouTube on how to bring down a certain exponent using log, and how to bring down a certain exponent using ln. So you can find a 2 minute or 1 minute video with the use of those function, log and ln, right? So we have here more examples. Example number 4, we have this, and then just by applying the 4 basic steps, then you will get this y. So I will leave the analysis part until you guys, since we don't have enough time anymore. And the same with this example. So just apply those 4 steps, and then you will get this one as your y, okay, or your inverse function. Anyway, this one is already super easy, so you guys can do this one on your own. All right, so once you're done with those examples, then you may now start in answering secret break number 7. Okay, so we have a to I. All right, so find the inverse function of the following. So you can base your answer with our examples, or from our examples. All right, so again, you can do this one in Microsoft Word or handwritten. All right, so are we clear so far for the inverse function?
Yes, sir.
Yes, sir.
All right, so tatawa ako. Parang I'm at the same time, I feel like ano bang English na naaawa? I pity you guys. Like, yeah, I feel poor for you, since in 2 hours you have to congest or absorb everything, and then do all the seat breaks, like 10 seat breaks, 9 seat breaks, within 1 week. And then considering that this is not your only subject, so you guys really have a lot of things to do. Anyway, so this is for your own benefit. So once you're done with your sufferings and then you were able to finish everything properly, then you'll just thank yourself in the future. Okay. So you will not become yourself in the future if you were not able to experience this kind of hardships. All right, so enough with those life advices. Anyway, we have this inverse function. So can we define the inverse of the following function? So we have this A3, B4, C1, etc., etc. So what is inverse of this function? So we cannot do the inverse function of this one since your range doesn't have a partner, or there's one of your domain that doesn't have a partner. Okay, so you can only do the inverse function if it's an unto function. Okay, no, actually. So if it's a bijection, so not only unto, but it should be a one-to-one function also. So one-to-one and then unto function. So that is the only time that you can do the inverse of this one. All right. So this one is also not one-to-one, so you cannot apply the inverse function for this one. Okay. All right. So we have here the compositions of functions. So you can just disregard this one for now. Basically, we have this f of g of a. Okay. So later on, I will discuss one by one what are the things that you need to consider for you to get the f of g of a. All right, so let's have this example. We have the f of x, your first function, and then your g of x, which is your second function. Okay, and then it is asking you the f of g. Okay, and then followed by your x. Your x here is always constant. Okay, so whatever is the value here will be replaced to the value of your g of x. So the very first step that you need to do here is the g of x. Okay, so look under the g of x, and then what is the value of your x? 1. So as you can see right here, just replace that x by 1. So 3 times 1 plus 2 is equals to 5, which is this one now. Okay, and then from there, we have the g of x, which is 5. So just replace the g of x into your f of x. So your x now here is 5. So 2 times 5 is 10 plus 3 is equal to 13. Okay, which is now this one. Or you can do this one in a long method, like this one. So we have replaced the x or the f of x by g of x, and then do the math. Okay, and then of course replace the x by 1, and you will get the same answer, which is 13. All right. So the first thing that you need to check is the value of your g of x, and then replace it to your g of x. And then once you're done solving your g of x, substitute it to your f of x, and then you will get the result as the same with this one. So were you guys able to follow this one?
Medyo, sir.
Medyo.
Medyo.
So a little,
Yes,
right?
sir.
That's because this diagram is quite confusing. So, well, actually, it's not confusing. It just takes time for you guys to analyze this one. So it might take you 2 minutes, 3 minutes to analyze this one. So that is why I told you guys to disregard this one for now, okay? Because we won't be able to come up with a solid definition of this one unless we have an example. Okay, so from there, just worry about the value of your g of x, and then substitute your g of x here, and then you will get this one. Anyway, I will leave this one to your part, whatever is your analysis. This one, as long as you will come up with the result of 13, then you're good to go. All right, let's have another example. So again, what is f of g of 2? So this is now the value of your g of x. So just substitute this 2 to your g of x. So 3 times 2 is 6 plus 2 is 8. So your g of x is 8. So whatever is the value of your g of x, just substitute that one to your f of x. So 2 times 8 is 16 plus 3 is equal to 19. All right. So seems like my way of solving this one is faster than explaining this one. Anyway, you can have this kind of solution or my own solution, just like what I did manually on my mind. Right. So it's impromptu, which is equal to 90. So how was it? Were you guys able to follow now at this 50%?
Sir, same lang ba yung yan tapos yung kanina?
No. This one is f of g of 1 before, and this one now is f of g of 2. Okay.
Sir, pero pwede gamitin yung nasa example 2.
Pardon?
Pero pwede gamitin yun sa example 2, sir.
Sa example, no, that depends on your function that is given to you, and then that also depends on your formula that is given to your first function and then formula of your second function. Okay. But basically, the same concept. Okay. Or same way of solving things, just a different expression. Right?
Sir, may tanong po ako.
Yes.
Sir, galing ba yung answer sa G of 2 yung 8? Pumunta ba sa F of 8? F8?
Ayun.
Or iba po sila?
This one, your G of 2.
Yes, sir.
Yes, this G of 2 goes to your F of 8 or F of X. So basically, you need to solve the value of G first before you can solve the value of F.
Okay, sir. Thank you, sir.
Okay. So do not solve the F first, solve the value of G first, wherein your X is 2. Okay. So that's how we've got the value of 8. Then once you're done with G of X, then substitute the value of your G to your F of X, which is now this one. So how we've come up with 19. All right, so any other questions so far? All right,
None, sir.
so I guess none.
Question.
Yes?
I said no question.
What?
I said no question.
No question. Okay, I heard I have a question. Anyway, so we have this next example, example number 3. So we have this g function 1a2a3c from the coordinates 1, 2, 3, and then abc. And then we have another function which is ay bx cz, and then from y to z is equal to xyz. So what is f of g? Okay, so actually the answer here is 1y, 2y, and then 3z. Anyway, so let me just show you guys this step by step on how did we come up with 1y, 2y, and then 3z. There you go. So basically just plot this one using a graph. So initially we have 1a, 1, 2, 3 first. So 1, 2, 3, and then a, b, c. A, B, C. So we have 1a, we have 2a, and then we have 3c. And then on the second function, we have ay, so x, y, z. We have ay, we have bx, and then we have cz, right? So from there, we can now conclude that the total functionalities is 1 going to, 1 going to y, and then 2 going to y, and then 3 going to z. So basically, we've just disregarded this middle one. Okay, so 1x, 1y, sorry, and then 2y, and then 3z. So that's how we've come up with those answers. All right, so understood so far?
Yes, sir.
Yes.
All right, so would you guys like to finish this module now or this next meeting?
Sir, sa next
Sir,
month,
baka naman. Next meeting na.
medyo
Next
lumab-
meeting. So, sayang, 13 slides na lang. Anyway, so we'll just continue the rest next meeting. Okay. So goodbye and oops. Wait. So answer seat work number 8. Okay. After example number 3, now start our discussion. Continue. Okay. Our discussion. Okay. So this is where we've stopped last meeting, seat work number 8. So this is where we are now. But before we continue this one, do you guys have clarification or questions regarding with your activities from
Sir, may nagpapasabi daw po, sir.
yes? Yun.
Sir, hindi daw po makakapasok si Cameron. Nasa hospital daw po, sir.
Ano nangyari? Alam mo kung ano nangyari? Kung bakit siya nasa hospital?
No, sir. Sinabi lang po sa akin na nasa hospital po.
I see. So I hope nothing too serious happened so that she can still, he or she, hindi ko alam kung lalaki ba siya babae, he or she can still take his final exam. Alright, so Mr. Cameron is here right now. So he said that he's using his mother's phone. Anyway, so this will just be a quick discussion. Alright, so are there no other question anymore? Or clarification or concern?
Wala na po, sir.
Alright. Okay, so for the next topic, we have here the applications of functions, wherein we have this mod, okay? Or in other words, we call this one modulo or modulo, okay? So this one refers to the remainder of the division written as x mod y, okay? So this one is actually similar with division, okay? It's just that it has a flip, yeah, a flip operator, all right? So if we have the divide, okay, or divide something like that, like 3 divided by 5, for the modulo, if you're going to read that one, 3 mod 5. All right, so it's a flip division operator. All right, and then if you're going to do this one, 3 divided by 5, of course, you will get, okay, let me just get my calculator. So you will get 0.6. Okay, at exactly 0.6. But if you're going to do the 3 mod 5, you will get 3. All right. So how did this happen? Because in modulus or modulo, okay, what we're trying to get is the remainder. Right. So what do we mean by remainder? So let me give you guys another example. So 6 modulo 5. So the remainder of this one is 1. Okay, so that's the answer for this one. So were you guys able to get the concept of modulo now? Or still not clear? All right, so I guess you guys didn't guess you didn't understand this one. All right, so let's have another example. 11 modulo 5. What is the result of this one? Anyone?
1.
Lucky guess. 1. All right, so as you can see, 11 divided by 5 is 1. Why? Because the remainder is 1. So it's like 5, 10, or like, doing the normal way of dividing things. 5 divided by 11. So 5 times 2 is 10. Remainder 11. Oops. So this one doesn't matter. What matters is the remainder. So this is our answer for this one. Right. Oops. Okay, so that's how we calculate mod. All right. So let us try to answer this example. Okay, so 6 mod 2 is equal to 0. 5 mod 1 is equal to 0. Actually, any number that is mod by 1 is 0. Okay, because as you can see right here, our condition for x and y are always positive integers. So we'll never get, okay, call this one a decimal. Okay, we'll never get 5.5, 6.5, 7.5, and so on and so forth. Okay, it is always positive integers, okay, where it's whole number. And then for the third one, 8 mod 12 is 8. Okay, and one more thing, if our divisor wasn't able to divide your numerator, then whatever is the value of your numerator, that will be your remainder. Okay, same with this one. Letter C. And then for the last one, 199,623 mod 2 is equal to 11. Okay. And yeah, as you can see right here, we also have here another pattern wherein if we have a result of uh, odd number that is divided by 2, the result is always 1. Okay. Well, uh, another condition here is as long as the numerator is greater than the denominator, right? The result here is always 1. But, to avoid confusion, you can just always use your calculator. Okay. So just get the remainder. All right. So were you guys able to understand this one now? The applications of functions mod?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Okay. So again, if you guys are confused, please let me know. Okay, so let's have another example. So let f be the function from x, 0, 1, 2, 3, 4 to x defined by f of x is equal to 4x mod 5. So here are the questions. So it says here, write f as a set of ordered pairs and draw the arrow diagram of the following or of f. Okay, so let's answer this one. All right, so I will list all of the x for now, and then we'll list them one by answering with the corresponding on x. Okay, so our x here is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. And then our another x wherein I'll just define it to y to avoid confusion or to have an easier way of calling this set. So we have here the f of x is equal to 4x mod 5. So if we have 0 for this x, so 4 times 0 is 0. So 0 mod 5 is 0. All right. And then if we have 1, so 4 times 1 is 4. 4 mod 5 is
4.
4. Can you guys follow?
Yes.
And if we have 2, so 4 times 2 is 8. 8 mod
8.
5 is how many? 8 mod 5.
Yeah, 3.
3. Right, very good. And if we have 3, so 4 times 3 is 12. 12 mod 5.
2.
Okay, very good. And if we have 4, so 4 times 4 is 16 divided by 5, or 16 mod
1.
5. 1. Right, very good. So it says here, write f as a set of ordered pairs and draw the arrow diagram of the following. So if you're going to put this in a set, so we have here 0, 0. We have here 1, 4. What's happening there? And then we have 2, 3. What is that? Right. 2, 3, and 3, 2. And lastly is 4, 1. Okay. So here's the set of ordered pairs. Oops, sorry, this one should be enclosed with parentheses. And then says here, draw the arrow diagram of the F. So just simply do this one. Okay. So here's now the arrow diagram of this function. Okay. And then for the last one is F 1 to 1 or onto. So what, guys? Is this 1 to 1?
Yes, sir.
This
Yes,
onto?
sir.
Okay. So if this is 1 to 1 and onto, what is that again? What is that relation? Where you guys forgot? So if it's 1 to 1 and onto, we call that one bijection. Alright. So this relation or this function is a bijection. Okay. So are we clear with this one?
Yes, sir.
Yes, sir.
All right. So next we have here the hash functions. So this one takes a data item to be stored or retrieved by computing the first choice for the location for the item. Okay. So basically this hash functions is came from the mod, okay, or the application of functions wherein it is connected with our database. Okay. So this is actually how the computer store our data with the use of hashing. Okay, like for example, we have n mod 11. So depending on the size of your memory, so like for example, for now we have a memory of 0 to 10. So take note, in memory we don't start with 1, or in computer we don't start with 1. We always start with 0. Okay, 0 and above. Okay, so as you guys can see, 0 to 10 is a total of 11 characters. So that is why it's mod 11. All right. So depending on the storage of your memory will be the limit of your modulus. All right, so let's have an example for you guys to appreciate this one. So start the following values in the memory using hash function. Right, and we have here data 15, 558, 32, 132, and so on and so forth. Okay, so as you guys can see, we have here cells 0 to 10, wherein some of them are already filled with those values 15, 558, 32, up to the 5. All right, so how did we put this 132 here, this 132 here? Okay, so for now, let's start with 15. So as you guys can see, 15 mod 11 or n mod 11. So everything, all of them are mod 11. It's just that it's changing the value or the one that you're going to store. Okay, so no matter how high, no matter how low that value is, okay, you need to perform this formula, mod 11, okay, depending on the size of your memory. Right, so 15 mod 11, as you guys can see, we have here a remainder of 4. So just look for that cell, which is this one. So first, so just store the 15 in there. We have 558 mod 11. We have a remainder of 8. Just store it on the 8th cell. 32 mod 11. We have here the 10th cell or the remainder of 10. So just put 32 there. 132 mod 11, we have 0, so just put the 132 in 0 cell. 102 mod 11 is equal to 3 or having a remainder of 3, so just put it on the 3rd cell. Okay, and then lastly, 5 mod 11 is a remainder of 5 or equal to 5, so just put the 5 on the 5th cell. All right, so as you guys can see, we still have enough space for the next datas. So for now, did you guys get on how did we put those data on our cell?
Yes, sir.
Yes, sir.
All right. So just follow this one, okay? So the one that you're looking for, the hash functions, is the count of cells or the count of memories or the memory itself, and then the n here or the data that you're going to store. All right, and then just follow this one, and you will be able to do this kind of answer also. All right, so here's the continuation. If h of x is equal to h of y, but x is not equal to y, then a collision occurs. What do you mean by collision? There is two data that is occupying the same cell number. All right. So for example, we have here 4,257 as a new data, okay, wherein of course we're still going to use this formula since we're storing that one in the same database or storage. So as you guys can see, we'll have or we'll get a remainder of 4, wherein our fourth cell is already contained by the data number 15. So we have a resolution for that one. So collision resolution policy. So used to solve collisions, so it may be finding the next highest unoccupied cell. So just look for the highest unoccupied cell. Okay. So we'll start with the lowest, of course, up to the highest. So just 4,257 will now go to your sixth cell. Okay. So you can only do this one if there is a collision. All right. If two data is occupying the same cell at the same time. Actually, not at the same time. So actually, in hashing, first comes first served. Okay, and then the next data will just find a new slot that you can go to. Okay, so for 4,257 will go to your sixth cell. All right, so that's how we call this one, how we store data in our database or storage in our computer, the use of hashing. So were you guys able to get this one so far?
Yes, sir.
All right.
Yes, sir.
So once you're done with those examples, then again, you may now start in answering this seat work number 9. Okay. So I will leave this one to you now. So let us now proceed to the next one, or to the last topic, which is the floor and ceiling of X. All right, so to make it short, when we say floor, so as you can see, it's the ground floor. Okay, it rounds down the number. And if we have the ceiling, so it's the above top portion, it rounds up the number. All right. So when we say floor and ceiling, so it doesn't matter what is your decimal. Okay. So unlike in normal way of rounding up or rounding down things, if it's uh, 0.4 and below, okay, you round down that number. And if it's 0.5 and above, then you round up the number. But in floor and ceiling, that's not how it works in this kind of uh, process. Okay, so as long as you have one uh, remainder or one decimal like 0.01, 0.1, or 0.0001, no matter how small it is. Okay, so you have to round it down if it's floor, and then you have to round it up if it's ceiling. All right, so as you guys can see right here, we have 8.3 will be round down, okay, which is now equal to 8, and then negative 8.7 will be more round down, which is negative 9. All right, so were you guys able to follow this one?
Yes, sir.
Okay, so don't get
Yes, sir.
confused in this one. Okay, this one just becomes more smaller. Okay, that's why it's gets more round down. Okay, we didn't round this one up. but instead we did round this one down. Okay, from negative 8.7 became negative 9, which is much more lower or lesser. All right, so we have the ceiling right here. If it's 6, or if it doesn't have a remainder or a decimal rather, then it will stay as it is. However, if it already have a remainder or a decimal, so even though it's 0.1 or 0.0001, then it will round up to the next number. So 9.1 will become 10. So the same with this one, your negative 11.3 will be round up. So this one will become negative 11. All right, and then negative 8 will stay as it is. All right, so did you guys get the idea of floor and ceiling?
Yes, sir.
Yes, sir.
All right, so let's have a graph representation here for the floor. Okay, so if it's ranging from 2.0 to 2.9, then it will be round down to 2. If we have 1.0 to 1.9, it will become 1. If it's 0 to 0.9, then it will become 0. If we have negative 0.1 to negative 1, it will become negative 1. Negative 1.1 to negative 2 is equal to negative 2. And negative 2.1 to negative 3 is equal to negative 3. Okay, so if we have a remainder, why do I keep on saying remainder? If we have a decimal, okay, so when it comes to flooring or floor, you will always go to the smallest or lowest number. All right. So this is the graph representation. This is the positive 1, positive 2, and positive 3. So we have here 2.0 to 2.9. So as you guys can see, this is the ground or the floor area. Okay, so it will fall on this one. So the same with this one, 1.0 to 1.9, it will fall on this one. This one, this one, this one, and this one. So this symbol is like I don't know how to say this one, but this one, okay, this one and this one, this is like the final coordinates of that uh, value. All right. So if you're going to plot this one, then you will plot it here, 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 here. So they are connected right there. All right. So were you guys able to follow this one?
Yes, sir.
Yes, sir.
All right. So we have here the graphs for the ceiling. So this is the opposite of your floor, of course. So as long as you have a remainder, if you have a decimal, okay, then it will be round up right away. So as you guys can see, we have 1.1 to 2. It will be round up to 2. So as you guys can see, the symbol is now flipped. Okay, so this is now the final coordinates. If we have 0.1, it will become 1. If we have negative 0.9, it will become 0. If we have negative 1.9, it will become negative 1. Negative 2.9 will become negative 2. All right, so those are their final coordinates. And then if you're going to plot this one, then you will plot it right here, 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 here. All right, so are we clear for this one?
Yes, sir.
Yes, sir.
All right, so this is the last one, plotting the graph. So this is just an example. So plot the graph of the function f of x is equal to 5 plus 3, and then we have here ceiling, okay, wherein our x's will start at 5. Oh, why? This one should be negative 5. All right, so there's a correction on this one. Negative 5 is less than or equal to x, or your x is ranging from negative 5 to 5. All right, so negative 5 to positive 5. All right, so let's try to answer this one. So again, correction. This one should be negative. Oops. -5. All right. So let's now list all of the ordered pairs for now. So F is equal to, all right, so I think it's kind of difficult in here. So we'll just use Notepad. F equal to, so how many ordered pairs do we have? 5, 10, 11. 4, 5, 6, 7, 8, 9, 10, 11. Right. Comma, comma, comma. All right. And then we have here the x, wherein it's starting from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and then 5. All right, so if we have a value of -5 for this x, so -5.1 will become -5, right? So -5 times 3 is -15. -15 plus 5 is +10. Okay, so I just did it manually. I hope you guys were able to follow on how did we get this +10. Sorry, -10, right? So for the next one, we have here -4. So -4.1 will become
4. -4.
-4. So -4 times 3 is -12, right?
-12.
-12 plus 5 is
-7.
-7. Okay. And then if we have -3, so -3.1 will become
-3.
-3. So -3 times 3 is -9
-9.
plus 5 is -4.
4.
As you guys can see, we already have a pattern in here. So it keeps on
Yeah.
adding 3, right?
Adding
So
3.
-10,
Yes.
-7, -4. Then we have here -1.
-1.
So plus 3 again, we have here 2.
2.
And if we have 0, so 0.1 will become 1. 1 times 3 plus 5 is 8.
2.
Right? So in here, it jumped from 3 to 5. Okay, so it's now plus 5. But of course, once we're done with the 0, it will become plus 3, plus 3, plus 3. All right, so if we have here +1, so 1.1 will become
2.
2. Okay, so 2 times 3 is 6, plus 5 is 11. So as you guys can see, it is now adding 3 and 3 and 10. So 8, 11, 14, 17, 20, and then 23. So if you are not convinced that this is the correct ordered pairs on every number for your x, so please verify those. All right.
So I have a question though.
Yes.
Our function, is it supposed to be -5 greater than or equals to x, or -5 less than or equals to x greater than or equals to 5? Less than or equals to 5.
Less than, yeah. Should be your x should be less than or equal to -5, and your x should be greater than or equal to 5. So
Greater
that is why
than?
we have the, yes?
I thought it's less than. We use -5 to 5.
Yeah, we've used -5, -4, -3, -2, -1, 0,
Yes.
1, 2, 3, 4, 5.
That means our x is less than or equals to 5, not greater than or equals to 5.
What do you mean?
I mean the function -5, it should be -5 less than or equals to x less than or equals to 5. But we have greater than in
I
the
see. So you're talking about the condition.
yes.
I see. So maybe this one is confusing. But what I mean on this one is your x is ranging from -5 to +5. Okay.
Yeah,
So the
I understand. I'm just worried maybe when we have an assignment, we won't get it wrong if you see a function like that.
in your assignment is what?
No, I said I'm just wondering maybe when we have an assignment so that we don't get it wrong if you see a function like that.
Pardon?
I said I'm only worried that in case we have an assignment or any function that has to be like this so that we don't get it wrong, so that the greater than or the less than sign doesn't confuse us. That's all right.
Yeah. So if there is another condition, then you have to follow that one. But in here, the condition here is already the function. Okay, so just follow this one, and then this is your x, and then your f of x is your y. Okay, so remember in plotting the graph for the f of x, where is that one again? Right here, your f of x here is actually your y. Right,
Yeah, I understand.
Okay.
The only thing I'm confused about is the function, the greater than and equals to, because if I'm to consider the greater than and equals to, then that means my x will be 6, I'll be 5, 6, 7, 8, 9, because it's greater than 5.
Ah, wait, let me check.
It said greater than or equals to 5. That's what I'm
Less
talking
than
about. This
-5. Ah, yeah.
it should be less than or
So,
equals to.
so this one is incorrect. Okay, my bad.
Yes.
So this one should be. So there is a correction on that one. This one should be 5 or equal a -5 your x, and then less than as or
or
equal
equals to.
to +5.
Yeah.
I see. Okay. So please do change this one into here. So this one is ranging from -5 to +5. Alright. So that is why Mr. Walawewe is confused. Alright, so thank you so much for this one. I didn't notice that this one is actually incorrect. Alright, so anyway, that's how we list the ordered pairs using the range of -5 to +5. So it says here, plot the graph of the function. So just make a graph. So the same with this one. Or is that the same with this one? Then you will get the line or the graph of that one. All right. And since you don't have enough time anymore, okay. So this is your seat work number 10. Okay. So yeah, that's it for the module 5. And then the coverage of your final exam is module 3 to module 5, of course. So any
Okay.
other concerns so far?
No,
Wala
sir.
naman po, sir.
All right, so I guess that's it. So good luck with your final exam this week. Okay, so I don't know the exact date, maybe Thursday. All right, so
Thank you,
goodbye,
sir.
guys, and thank you.
Bye.
Thank you,
Bye,
sir.
sir.
Thank you po.
Bye, sir.
Goodbye.
Bye, sir.